there, my sweet perfect angels. And to my not so sweet, not so perfect angels too, y'all got a seat at the table. Welcome to our first flipped classroom video of Unit 3. Clap, 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 clap. For the past couple weeks, by way of the inequalities we've been working with over the course of Unit 2, we've gotten, at least in theory, super familiar with using and reading the number line. But if we're talking about number lines, there's one really important thing connected to them that we haven't explicitly talked about since Unit 0. And if we're doing that, we should probably chat about absolute value. Specifically, we're going to see how absolute value impacts the way that we might solve some equations and inequalities. So starting with, in our first class of Unit 3, some absolute value equations. Now if I'm going to do that, remind me, what is absolute value actually? What's its definition? 5, 4, 3, 2. Let's dance. Well, absolute value by definition, you hopefully remember we defined it not just as an operation, but as a measure of distance. Specifically, on a number line, it's the distance between a number and 0. So if I give you something like the absolute value of 11, I know how to find it, right? Absolute value of 11 is, of course, 11. Same thing with 0, same thing with -4. Take 10 seconds, pause the video. What are the absolute values of these numbers? Maybe you did, maybe you didn't. I don't know. Absolute value of 0 is 0. And the absolute value of -4 becomes +4. The idea, of course, being, if I give myself my number line, we're going to pretend this is a nice, pretty perfect number line. If I'm counting from 0 to 11, well, on that number line, I need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're going to pretend those are evenly spaced tick marks. So I count 11 units to get from 0 to 11. Same thing for -4, right? -4 is on the other side of 0, but I would imagine that I'm counting 1, 2, 3, 4 units are doing 4 jumps to get from 0 to -4. And then for 0, of course, right, if I'm trying to find its absolute value, I don't have to move at all. So I'm not measuring any distance at all. So if we want to be really explicit with what's happening, we can algebraically define how to calculate the absolute value of a number. So if I'm taking an absolute value of a number, there are 3 types of numbers I could be working with. Well, a number could be one of 3 things. What 3 things could it be? 5, 4, 3, 2, 1. Well, big picture on the number line. A number could be positive. One way to write positive numbers are to the right of 0. So if x is greater than 0, it's positive. Another option, right, it could be equal to 0. And of course, it could be less than 0. In other words, negative. Well, hopefully you've noticed that absolute value is always what kind of number? Well, it's always going to be positive. It's always got a sunny disposition. It's always happy. It's got a positive outlook on life. It's a positive number. So if I'm taking the absolute value of a positive number, well, the output is positive. So I'm not doing anything to the number, right? It's just the number itself. Same thing to 0, right? 0 is its own absolute value. So if x is equal to 0, the absolute value of x is going to be 0. But if the absolute value of a negative number is being taken, well, the thing that happens is that every negative becomes positive. I flip the sign. So to change a negative to a positive, one thing you can think about is taking your number and multiplying it by -1. So if I take x and x is negative, to turn it into a positive x, I would need to multiply by -1. Cool. Maybe this definition works for you. Maybe it doesn't. Either way, absolute value is always positive. And I know that it's talking about distance on the number line. So knowing how to find the absolute value of a number, what if I tell you in reverse what the number has an absolute value of? So let's say the absolute value of x is 2. The thing that I'm asking you is what number could it have been? So the way that I like to think of this, I like to think of a lot of things like questions, hopefully you've noticed. The question I like to ask myself here, what could be inside the absolute value here? So I know that when I take the absolute value of x, I get 2. What numbers could I take the absolute value of to get 2? Is there 1? Is there 2? Are there none of them? I don't know. But what number could be inside the absolute value here? Take 20 seconds, pause the video. What could x be? Go. 5, 4, 3, 2, 1. Well, if I think on the number line, what I'm asking for is what things are 2 units away from 0? Well, I have 2 options. I could go to the right, and if I do that, counting 2 to the right would get me to 2. So there's one option. But if I counted 2 to the left, if I take the absolute value of -2, would I still get 2? Well, yeah. So I've got 2 options here. I can say that x is equal to -2, or, and if you want to, you can even use your funky symbol. You've got it, you might as well. Right, x could be -2 or +2. So what this hopefully tells us here by visualizing using the number line, when I'm finding a number inside of an absolute value, there are 2 cases. I've got 2 options, right? It could be the positive version of the number, or it could be the negative version of the number. Because either way, taking the absolute value of a positive or a negative will still give me a positive output. Same thing with these 3 below. What are each of these numbers possibly? What could y be if its absolute value is 38? Same thing with z, same thing with w. Take 30 seconds, pause the video. Have fun. Alrighty, well, if the absolute value of y is equal to 38, again, the question I could ask is what could be inside the absolute value? Well, if I take the absolute value of 38, I could get 38. Or I could take the absolute value of -38. That would work for me too. Same thing with z here. Z could be positive 17 over 2. That has an absolute value of 17 over 2. Or z could be equal to negative 17 over 2. It could be either of those. And if I take the absolute value of 0, that's the only thing that will get me 0. So this is like our trivial case. As we defined above, the only thing that has an absolute value of 0 is 0. Cool. So with all of this in mind, we know how to find the absolute value of a number. We also know how to reverse engineer a number if I know its absolute value. The only thing that remains for us to discuss then is, well, what does this mean for us if we try to solve some equations with absolute value bars in them? So I've got the absolute value of h minus 4 minus 1 is equal to 5. I want to think strategically. Again, what does it mean to solve an equation? And what do I do to accomplish that goal? Oh, we've said it so many times, and the way that you just screamed it out made me so happy. To solve an equation means to make it true. And in order to do that, I need to isolate the variable. So if I want to get h by itself, well, I need to think about the things that are in the way. I've got a -4, I've got a -1, and then the new thing is that I've got an absolute value. Take 30 seconds in game plan here, not expecting you to come up with anything necessarily, but what series of choices would I need to make in order to get rid of all of these things and now to solve this problem that the absolute value bars are introducing? Okay, maybe you've percolated, maybe you haven't. If you haven't, I'll percolate for you. So I want to get rid of some absolute value bars. I know from above that if I can get the absolute value to a place where it's the only thing on the side of the equation, I can split it into my positive and negative cases. I might also think about trying to get rid of that -4. But before I can get rid of the -4, remember we said something in Unit 0 about absolute value. What is it an example of? 5, 4, 3, 2, 1. Well, just like parentheses, just like a fraction bar, absolute value is an example of a grouping symbol. And what that tells me is that I can't get rid of the -4 attached to the h until the absolute value bars go away. So I need to find a way to get absolute value gone. And that happens, as we saw above, when I can get absolute value by itself. So step 1 of my strategy should be to get my absolute value bars alone. I want to get them by themselves. I want to cut them off from their family and friends and make them suffer in their sadness and loneliness. Okay, I'm kidding. I don't want to make them suffer. I just want them to go away. I just want them to leave me alone. So I want to get the absolute value by itself. First choice I might make then, well, I've got a -1 outside that I can get rid of. Let's add 1 to both sides. When I do that on the left, these undo each other. I'm left with the absolute value of h minus 4 is equal to 6. And now, knowing what I know about how I could reverse engineer the number inside of the absolute value, what 2 equations could I write? Go. 5, 4, 3, 2, 1. Okay. Well, again, the question that I like to ask is what could have been inside of the absolute value to get 6? So step 2, now I'm going to do my split. I'm going to split up my absolute value. As we saw above, I've got 2 options. There's a positive and there's a negative case. So if the thing inside the absolute value has an absolute value of 6, then the thing inside the absolute value, in this case the h minus 4, it could have been positive 6, or it could have been negative 6, right? It had to be either positive 6 or negative 6 if when I took its absolute value, I got 6. And now that I'm here, I've got some nice linear equations that I know how to solve. So my last move is going to be to solve each of my linear equations. Well, if h minus 4 is equal to 6, to get h by itself, I would add 4 to both sides. On the left side, they undo each other, and I've got h is equal to 10. So my first option is that h could be 10, but in my other case, I have h minus 4 could be negative 6. So adding 4 to both sides here, I would find that h could also be negative 2. Alrighty, so we've got our solutions here. But back in Unit 2, we did a whole bunch of stuff with number lines, absolute values really connected to number lines. Why not? Let's put it on the number line and see what happens. How do you think I would graph this? Take 30 seconds, come up with a game plan, take a risk, take a chance, who cares? How might I plot this on the number line? Go. Alrighty, well, hopefully, if I've got a -2 and a 10, probably want to put the -2 and the 10 on the number line. And notice here, both of these are equal to. On a number line, when a value could have been equal to something in the solution set, what symbol did we use? Well, equal to is indicated by a closed circle. So both -2 and 10 can get closed circles on the number line. They're parts of the solution set. They're included. And then I don't have anything to the left. I don't have anything to the right. It's just the -2 and the 10. So I don't need to color in anything else on my number line. It's not a sandwich. It's not a split. It's just, weirdly enough, exactly those 2 numbers. Even more fun, I can also use my notations. Let's write our set builder and interval notations for this. Set builder notation always begins with 5, 4, 3, 2, 1, a squiggle, followed by 5, 4, 3, 2, 1, a variable, followed by 5, 4, 3, 2, 1, a vertical bar indicating such that. So here, what's my criteria that I need to meet? Well, again, set builder notation is always populated by the thing that I end up with once I've solved. So in this case, I solved and I got that h could be 10 or that h could be 2, or in this case, -2. But notice that this notation is kind of clunky for just having 2 numbers. So mathematicians noticed that and they said, hey, well, let's come up with a little bit of an abbreviation for this, or a shorthand, if you will. My shorthand for the set builder notation, it's still going to begin and end with our squiggles. That was a terrible squiggle. So I'm going to draw my squiggly bracket, my squiggly bracket. But the only things in the solution set are 10 and -2. And mathematically, we often like to order things in increasing order. So my shorthand looks instead like this. -2 is smaller than 10, so it's going to come first. And then I'll separate with a comma, not unlike the interval notation that we wrote. and then end with 10. So this tells me in my solution set, the only two things are -2 and 10. Interval notation is a little wonky. You're welcome to pause and think about it if you'd like. I'll write it out for you. Interval notation. Well, the two things on the number line are the -2 and the 10. I can't be both of them, so it's going to be joined, just like in the set builder that we wrote, with an or. -2 and 10 both have closed circles, which indicate in interval notation they should both get a 5, 4, 3, 2, 1, a bracket. But we didn't go to the left or to the right, so I don't need to add anything to the left or the right. This is what our interval notation is going to look like. It's just the -2 and the 10, and both of them are included, so both of them are just going to get surrounded with our brackets. Okay, let's do one more for the road. Take this guy, -5 times the absolute value of 10 minus p is equal to -10. I want to get the absolute value by itself. I want to graph it. I want to write our set builder and interval notations. Give yourself some time. Take 2 minutes, pause the video, see what you come up with. Have fun. Okie dokie. So I want to get absolute value by itself. Notice -5 is the only thing outside of the absolute value still connected to it. So I'm going to divide both sides by -5 to eliminate it. So I've got the absolute value of 10 minus p is equal to 2. Now that I'm here, step 2, absolute value by itself, let's split. So my two options, if the absolute value of 10 minus p is 2, then the stuff inside the absolute value, the 10 minus p, it could be +2, or it could be -2, right? If its absolute value is 2, either it was +2 or -2. And from here, all I've got to do is solve for p. Well, I'll start by minusing 10 from both sides. On the left side, I've got -p. On the right side, 2 minus 10 is -8. If -p is -8, again, I want just p by itself. Well, if I flipped the sign of p, I'll flip the sign of the -8. So p could be 8. Or my other option, if 10 minus p is -2, start by minusing 10 from both sides. On the left, they undo each other. You've got -p is equal to -12. And if -p is -12, then +p is +12. On our number line, the two things that need to go on the number line are me and myself, 8 and 12. So I'm going to put 8 and 12 on my number line. I'll label my variable p if I want to. Again, don't have to. Both of them are equal to, so both of them get a closed circle. And then I don't have anything to the left or the right. These are the only two things in my number line. That's my graph. We'll end with our set builder and interval notation. Set builder, right? I'll write my shorthand here. Again, my squiggly bracket in my solution set are just 8 and 12. 8 is smaller, so it would go first, followed by the 12, and then we'll close our squiggle. And then our interval notation, I'll start with a bracket around the 8, or I could be at 12. Alrighty. Congratulations, my friends. You made it to the first class of Unit 1. With more time, right, I would give you the following two problems, but I want to make sure that I'm honoring your requests to keep our videos a little shorter. So, with this in mind, you've got these two. These will be our warm-up when we come in next time. If you'd like to solve them ahead of time, be my guest. If you want to wait until class, that's perfectly fine too. Thank you, my dears. Have a lovely rest of your day. Take care, be good, and goodbye.